Assalamualaikum dan salam sejahtera. My name is Nur Izzayu binti Muhammad Jamka. I'm from FTKE and my title is Development of IoT-based lighting control system for energy efficiency smart building. Okay, we can see for introduction. The purpose is to build an effective and energy efficient lighting system by detecting the current lighting environment and altering the light appropriately. IoT is a network of physical and digital device equipment and items that may be used to monitor and control the range of things in the environment, include building, which use the majority in many countries. For the problem statement, our economy is now experiencing a severe energy crisis. While away from the home, people often forget to switch off and other hold at place. Home automation enables us to easily operate them from a remote location using our smartphone. In summary, we may reclaim valuable time and increase our productivity. Objectives for this project. First, to develop an IoT-based lighting control system for energy efficient smart building using Arduino. Second objective is to evaluate the performance of the developed system in terms of its reliability in real environment. And the final objective is to evaluate the energy consumption in the building which the development system. And then for the methodology, we can see which is the flow chart. First we start and then the sensor present people, which is using PIR sensor. And then if yes, LDR sensor detect light intensity is above 70%. If yes, light will off, while no, light off. And then send data via Wi-Fi module to Blink application. And then that's all for project. For software, we use Blink software, and then for coding, we use Arduino IDE. Block diagram for hardware requirement, people. For input, we put people, PR sensor, and LDR sensor. And process is ESP8266 Wi-Fi module and Arduino Uno, and the output is LCD display. I'm use the voltmeter to display the voltage. And then my result and discussion. Okay, we can see the experiment 1. We can see the room 1 and room 2 have movement detection and the light intensity below than 70%, and the result of LED will on, which is room 1 and room 2, the light will on. And then for the overview of the Blink application, we can see the switch 1 and switch 2. Actually, switch 1, this part is part 1, which is the manual user. User can use the button has a manual. And then for the part 2 is the button that user can see at the room have movement or not. Okay, the result on the Blink at part 1. We can see the room 1 and room 2 is off, And then for part 2, wish on. And then for scenario 2, we can see the room got movement and room 2 no. While the light intensity below 70%, the room 1 have yes and room 2 no. So the result LED will on at room 1 and off at room 2. For the blink application, we can see at the part 2, the room 1 on and room 2 is off. After that, movement detection at room 2 and the light will on at room 2. Same also the blink application, we can see at the blink. And then for experiment 2, no movement detection. We can see no movement detection, but we control the manual at the blink. We on the LED and the light is on. And then for next, we on LED at room 2 and the light is on. The movement, we don't have movement. And the last one is we on 2 room together. No movement and the light will on. And then we can see at the for other result and experiment. I'm select 3 scenario for, and then I do experiment at the energy efficiency smart building, which system, and the conventional system, which is this have is manual system and then which system. And for scenario 1, the experiment is conducted for 3 hours, and the user will enter the room every 1 hour's interval time and stay in the room for 30 minutes. For example, user will leave the room for 30 minute duration. And the result we get, currently voltage is never. After the completing the scenario, voltage was dropped until 6.8 volt. So total voltage used at this system only 2.2 volt. But for conventional system, currently is 6.8 volt. After the completing the scenario, voltage was dropped until 4.3. So the total voltage was used at this system only 2.5 volt. While for scenario 2, the experiment is conducted for 1 hour. The user will enter the room and stay for 15 minutes duration. Then the user will leave the room for 40 minutes and enter the room and stay for only for 5 minutes before leaving. You can see result at scenario 2. Currently voltage is 8.3 volt. After the completing the scenario, voltage was dropped until 75 voltage. So total voltage used at this system only 0.8 volt. While the for CS system, currently voltage is 6.3 volt. After the scenario complete, the voltage dropped 5.1. So the total voltage used is 1.2. The last scenario is the experiment is conducted for 20 minutes only. The user will enter the room every 5 minutes and stay for the maximum 5 minutes duration. Currently voltage is 75 volt. After completing the scenario, voltage was dropped until 7.3. So total voltage used is 0.2 only. While for CS system, only use 1 voltage. This is comparison to third scenario if energy efficiency smart building system and a conventional system. And then this is a graph show that the battery consumption which the proposed IoT-based system is always lower than the conventional system. His is more energy efficient. For this part, I will explain about a potential commercialization. The project aims to create an IoT-based lighting management system for energy efficiency smart building. This system can provide attractive business opportunity because of its cheap equipment costs, low maintenance costs, and easy infrastructure. It also improves energy efficiency in buildings such as university lecture, teacher room, and other. And the last one is conclusion. Finally, this technology has the potential to solve energy efficiency problem. There are many uses for smart building and they have many advantages. One of them is that they increase the efficiency of the building because PRL sensor and LDR sensor help optimize energy consumption. IoT-based smart lighting system is reliable in real environment system that can observe all the conditions in the room. The user can also check the room using the Blink application to see the presence of user. The system can evaluate the energy consumption in the building, which the developed system was do comparing lighting with system and no system. Finally, the objective of this project has been achieved successfully. For reference, I refer to design of intelligent lighting system based on Wi-Fi and Arduino Single from RLU. And then for next reference is IoT-based smart light intelligent weather and color adaptive system in light. And the next is an IoT smart lighting system for university classroom. That's all for me. Thank you.